Welcome everyone. Myself Shaheed-ul Islam is going to present video lecture session today from Leading Institute platform. We will be solving here NEET major test physics paper. Dear student, everything we do is practice for something greater than where we currently are. Practice only makes perfection. I can only attempt the problems to improve the condition in which you can learn. I must mention here for my student that knowledge is of no use unless you put it into practice. Time to move on to the problems. The first problem here, the incorrect statement for concave mirror producing virtual image of the object is. You know, concave mirror, if we place the object inside the focus, we can get the virtual image of the real object, and the magnification of this virtual object is always greater than 1. So magnification of virtual image by converging mirror is always greater than 1. The linear magnification is always greater than 1 except at pole. This is correct statement, but here the question is incorrect statement. The linear magnification is always less than 1. So this is incorrect statement and right option. Next problem. A ray passing through or directed towards the center of curvature of a spherical mirror is reflected such that it traces back of its path, because you know, spherical mirror, let us say this is one spherical mirror and the light passing through center of curvature is incident normally, that is angle of incidence is equal to 0. If the angle of incidence is 0, we can say angle of reflection it is also equal to 0. So right option here, angle of incidence is 0. If the light is incident through center of curvature of a mirror, then we can say the light falls perpendicularly to the mirror and the angle of incidence is I equal to 0 and angle of reflection is also 0. So reflected and it will retrace the same path. So therefore we can say the angle of incidence here is 0. So right option here is 2. Next problem. A beaker of depth A is half filled with olive oil of refractive index μ1. A container contains half of the depth, that is A by 2, and the refractive index of the oil is μ1. Another half of the container of depth, it is A by 2 and the refractive index of this part is μ2. So any container contains the different liquid of refractive index mu1, mu2, mu3 such as in a way that we can say the apparent depth is equal to d1 is the depth of the liquid of refractive index mu1 and d2 is the depth of the refractive index mu2, and generally we can say the apparent depth summation of this d by mu I equal to 1 to n. So here the problem, two type of liquid, we can say the apparent depth, the depth of the liquid of refractive index mu1 and depth of this is a by 2 refractive index mu1, and the depth of the other liquid is it is also a by 2 and refractive index mu2. So similarly, by simple calculation it is 1 by mu1 plus 1 by mu2, and finally it is a mu1 plus mu2 by 2 mu1 mu2. So correct option here is 1. Next problem, an object is placed in a front of spherical radius r at a distance x from the first surface. It is spherical, an object is placed in front of a sphere of radius r. An object is placed at a distance x. The value of x for which the after diffraction from the first surface becomes parallel to axis, and the radius of curvature of the sphere is r. This is r. Let us say the refractive index of the medium is mu2 of the mu2, that is of the sphere, and the light rays after diffraction it becomes parallel to the principal axis. First we have to know what is the formula have to be used in this type of problem. Here refraction taken place from medium 1 to medium 2. So right hand side of the equation it is mu2 minus mu1 by radius of curvature. Diffraction taken place from medium 1 to medium 2. So this is final medium. So you have to write here in the right hand side of the equation mu2 minus mu1 by r, and in the similar order mu2 by v, and it is mu1 by u. So this is the formula for solving this type of problem. First you have to write this formula correctly. Okay. By question. By question, since the light after refraction becomes parallel, so we can say v equal to infinity, and u it is actually minus x, and radius of curvature, this is the radius of curvature, and we have to proceed along the direction of light. So radius of curvature it is actually plus r, and if we measure the distance of object, we have to proceed against the direction of light, so it is negative. So just by putting this in the formula, we can say it is mu1 minus mu1 by minus x, and it is mu2 minus mu1 by plus r. Therefore, x is equal to r mu1 mu2 minus mu1. So this is the distance of the object for which light rays after refraction becomes parallel to the principal axis of the sphere. Okay, so right option here, since you know mu1 here is the medium is 1, the refractive index of the air is 1, so x is equal to becomes r by mu minus 1. So correct option matches with 1. Next problem. Two identical thin plano convex glass lenses is having radius of curvature 20 cm placed with their convex surface in contact. So this is the combination of the lens. This is refractive index is equal to 1.7, and refractive index of this part is, it is glass, it is 1.5 given as per the problem. Mu g. You have to find out the focal length of this combination. You know, if we incident a light, parallel light incident upon this, so focal length is equal to 1 by f. Refractive index, it is mu air, it is equal to 1. So the formula is equal to refraction taken place at the first surface from air to glass at the plane surface, that is mu g minus mu air by radius of curvature of the plane surface is infinity. So first refraction plus second diffraction taken place from the glass to liquid. So refractive index of this part is 1.7, and refraction taken place from the medium glass, it is 1.5, and radius of curvature minus 20 centimeter. The radius of curvature of this spherical surface is equal to, the center of curvature is left hand side. So if we want to measure the radius of curvature of the spherical surface, we have to proceed against the direction of light. So radius of curvature is minus 20 centimeter. Third refraction taken place from liquid of 1.72 into the glass. So 1.5 minus 1.7 by, we know if we find the radius of curvature of the spherical surface, we have to proceed along the direction of light, because light is incident upon the combination from the left hand side. So radius of curvature is 20, and the last refraction, that is from glass to air, refractive index of air minus refractive index of glass by radius of curvature of the plane surface is infinity. Finally, minus 1.75 by 20, and it is 1.7 minus 1.5 by 20. We can say minus 2 into 0.2 by 20. And it is minus 4 by 200. And focal length is equal to minus 50 centimeter. So we can solve this problem by considering the formula. You have to just keep in mind from what medium to which medium the refraction taken place. If the refraction taken place from air to glass, then you have to write glass minus air by infinity, and the refraction taken place from 1.5 of medium of refractive index 1.5 into the liquid of refractive index 1.7. So 1.7 minus 1.5 minus 20. In this way, we can write the formula of the focal length of the combination directly, rather using the formula for the combination of lenses. Here is the combination of 3 lenses, but if we use the formula of the combination, then the problem becomes very large, calculation becomes very large. So better you have to use the formula of focal length from the lens maker equation, and finally the focal length becomes minus 50 centimeter. Right option here is 3. Next problem. White light is incident on one of the refracting surface of a prism of angle 5 degree. Refractive indices for red and blue colors. It is actually prism. You have to take the thin prism, you know. Angular separation between these two colors. We know deviation of ray, delta is equal to A mu minus 1. So deviation for red color, it is A mu refractive index of the prism with respect to red color minus 1, and refractive index for blue color, it is 1.659 respectively. For blue color, it is A mu blue minus 1, an angular separation. You know, deviation for blue color is greater than the deviation of red color, because you know the refractive index of the prism, refractive index of this prism with respect to blue color is greater than the refractive index with respect to red color. So angular separation theta, we can say it is dB minus d delta r, delta B minus delta r, and it becomes A delta B minus, A into refractive index of prism with respect to blue color minus refractive index of the prism with respect to red color. Okay. So this is angular separation between these two colors when emerge out of the prism. prism angle, it is given 5 degree, and you know 1.659 minus 1.641, and it is 5 degree into 0.018, and it is 0.9 degree. Five into 0.9. Sorry, be careful. So right option here is 2. Next problem. Chromatic aberration is formation of a dull image in white, no, formation of a tilted image in white light, formation of deformed image in white light, formation of colored image in white light. So right option here is 4. In a case of lens, you know, lens maker formula, it is mu minus 1 by R1 minus 1 by R2. And from Cauchy formula, mu varies 1 by lambda square. Cauchy formula. So therefore we can say focal length of lens is directly proportional to the square of the wavelength used. So focal length of lens also varies with the different color. So if we incident a white color here, white color is incident upon this. We know in case of VIBGYOR, wavelength violet less than wavelength yellow less than wavelength red. So focal length with respect to violet color is less than the with respect to yellow color, and focal length is maximum for red color. So for a lens, for any lens, the focal length of this lens is different for the different color. So focal length for the red color is maximum, and focal length for this lens in the case of violet color is minimum. That is least value for the violet color. And if we incident a white light, so what happened? Focal length for red color is maximum, so this is the focal length for the red color, and focal length for violet color is minimum. So because of the different focal length with respect to different colors, we can get the color image of an object, and the defect in the formation of image due to color is known as chromatic aberration. So right option here, formation of colored image in white light. Next problem. In an astronomical telescope, a normal adjustment, a straight black line of length L is drawn on inside part. It is objective. Objective lens. And do you know, it is eyepiece. This lens is known as eyepiece. Straight black line of length is drawn. Straight black line is drawn inside the objective lens, inside part of objective lens. Eyepiece forms a real image of this line, and the length of this line is I, and for this line, you know, a real image is formed. A real image is formed A real image is formed. A real image is formed A real image is formed of length I. Length of the image, length of the object of the line drawn inside the telescope objective lens is L, and the length of the image is I. So simply magnification. It is actually, I am talking about linear magnification. Linear magnification M is equal to, from the Newtonian concept, we can say it is F by X and it is Fe by UE minus Fe. It is the linear magnification. Therefore, we can say Fe, focal length of eyepiece, and you know the object distance is equal to FO plus Fe. Object distance, that is the distance between two lenses. Since this telescope is an astronomical telescope, normal adjustment. In the case of normal adjustment, the length between two lenses is equal to FO plus, better to say, distance between two lenses. Distance between two lenses is equal to FO plus Fe. It is in the case of normal adjustment. Normal adjustment means the focusing final image formed at the infinity. An astronomical telescope when it is focused at infinity, that is final image formed at infinity, the foci, that the distance between two lengths, that is the telescope length, is equal to FO plus FE. So in this case, for the eyepiece lens, the object distance, that is the black line drawn on the inside side of the objective lens, it is the object distance for eyepiece lens. So UE is equal to FO plus FE minus FE, and finally it becomes FE by FO. This is the linear magnification of the image formed by the eyepiece of the line drawn of the objective telescope. And we know, since it is given magnification, it is equal to FE by FO. It is actually linear magnification of this image, and it is I by L, as it is given in the problem. So first we have to find out the linear magnification. Linear magnification of the image formed by the eyepiece. It is actually information given in the problem, but actually the problem is just the angular magnification of the telescope at normal adjustment. So from here we can find the linear magnification. Linear magnification is equal to, in terms of focal length, FE by FO equal to I by L. But you know, when telescope is at normal adjustment, that is focusing at infinity, the angular magnification of a telescope when focusing is at infinity for the astronomical object, it is actually FO by FE. It is angular magnification. But from the information given in the problem, we have find out already linear magnification of the image formed of the black line drawn inside the objective lens. And you know, here linear magnification already being calculated, it is FE by FO, okay, is equal to I by L. But the angular magnification is equal to FO by FE, that is focal length of the objective lens by focal length of the eyepiece, and it is finally L by I. Right option here matches with 4. Let us see the next problem of this video session. Limitation of reflecting telescope. It is informative based problem. You have to go through the theoretical part of the telescope. The limitation of the reflecting telescope here is objective mirror focuses the light inside the telescope tube. So this is the right option here. Next problem. A small bulb is placed at a tank of containing water. A light source is placed inside the water. The light can emerge out, This is the angle theta C, and this is the angle theta C, and we know this is the cone through which the light can emerge out, and maximum angle of incidence, it is theta c because maximum angle of refraction is 90, इससे ज़्यादा नहीं हो सकते. So therefore the maximum angle of incidence is theta c, and if we say the height of the source is h and this is the radius, by geometry this angle is theta c, we can write here r by h. R by h is equal to tan theta c. So r is the radius of the cone through which the light can come out from the light source placed inside the liquid at a particular depth, and the radius is equal to h tan theta c, and we know sin theta c is equal to 1 by mu. From the total internal reflection, we can say the sin theta c is equal to 1 by mu. Mu is the refractive index of denser medium with respect to rarer medium. So tan theta c, it is h by root over mu square minus 1. So for this particular type of problem, my recommendation for you just directly use this formula, mu square minus 1, r is the radius of the cone, radius of the base of the cone through which the light emerges out. Since it is water, so if we put the value of refractive index mu, then r is equal to, it is 3h by root 7. H is the depth, and you know from the problem it is 80 centimeter root 7, it is centimeter. But we have to find out of the area, the base area of the cone. We have to find out the base area of this cone, and area is equal to pi r square, and it is 22 by 7 into 9 into 64 into 10 to the power 2 by 7, and by simple calculation, you just pause this video and calculate this problem. It is actually 2.58 meter square, though the height is given there is in centimeter, but finally you have to convert it into the meter square because option given here meter square, all are meter square. So correct option here is 2. Next problem. An object approaches a convergent lens from left of the lens. Since the object moves towards the lens, since the object is moved towards the lens, so image is moves away from the lens. Here we can say immediately after this, applying this concept, when any object moves towards the lens, an image moves away from the lens. So immediately just applying this concept, we can say the option 4 is not the right option, but rest of all moves away. Now we have to justify You have to go through whole the statement of the option. Moves away from the lens with an uniform speed. You know the velocity of image equal to m square velocity of object. M is the linear magnification. Linear magnification. If v equal to is a constant speed of object given in the problem, but the velocity of image depends on the linear magnification, and you know linear magnification sometimes it is greater than 1, less than 1 or equal to 1, so magnification changes. So it is not possible the image moves with an uniform velocity. So 1 is not the right option here. Moves away from the lens with uniform acceleration. It is also not true, though the velocity of the image changes, but this change is not uniform. Velocity change is not uniform. You know, so option 2 is also not the right option. Moves away from the lens with non-uniform acceleration. 3 is the right option. Okay. Next problem. A resistance of 300 ohm and inductance of 1/5 Henry are connected in a series AC of 20 volt 2000 Hertz frequency. Phase angle between voltage and current. You know tan phi in any AC current when the circuit is inductive, we can say tan phi is equal to omega L by R. I mean to say inductive reactance by resistance, ohmic resistance. Okay. And simple problem, this is very simple problem. Twice pi f into L by R, and it is twice pi, frequency is 200 and inductance is 1/pi and the resistance equal to 300, and finally it is 4/3. So phi, that is phase angle between voltage and current, it is equal to tan inverse 4/3. Correct option here is 1. Next problem. Frequency is double. What happens to the capacitive reactance and the current? We know capacitive reactance Xc equal to 1/omega c. Omega is the angular frequency of the AC source, and C is the capacitance of the condenser, and it is 1/2 pi f into C. F is the frequency, that is the rotation of the coil per second in a generator. Rotation per second of coil in magnetic field in a generator is the frequency of the AC current or AC source. You know, Xc increases if the frequency decreases as Xc proportional to 1/f. If the frequency is double, so we can say frequency is double, that is Xc. If the frequency is double, then we can say Xc becomes half. Capacitive reactance is halved. So frequency is double. Xc definitely it becomes half. You know, Xc inversely proportional to the frequency. Similarly, current, circuit current. Let us say the RMS current of this circuit, it is RMS current or any current, you know, instantaneous current, RMS current or peak current, whatever may be. I am taking here the RMS current. It is actually RMS voltage by Xc. Since this Xc is halved, so current becomes double. Capacitive reactance is halved and current is double. Okay, so correct option matches with 1. Let us see the next problem. An LCR series circuit consists of resistance of 10 ohm and a capacitive reactance 60 ohm and inductor coil. The circuit is found to be at resonate when put across 300 volt 100 Hz supply. Okay. We know in series resonance circuit, LCR circuit, resonance angular frequency omega naught, it is 1 by root over LC. And 1 by root over LC equal to omega naught, and omega naught is equal to twice pi f naught. As per the problem, the value of pi, it is 3 since the given in the problem, and the frequency you know 100 Hz. So this is 600 rad per second. Okay. So we have to find out the value of C. You know, Xc is equal to 1 by omega C. Omega naught C, here C is equal to 1 by omega naught into Xc. One by omega naught into Xc. and already we omega naught is equal to, it is 600 and it is 60. So therefore 1 by 36 into 10 to the power 3 farad. And you know, again we can say little bit calculative problem in this time, you know, 1 by LC equal to omega naught square. We have to find out the inductance of the coil. So L is equal to 1 by C into omega naught square. And it is 1. If we put the value of C, it is 36 into 10 to the power 3, and omega naught is already 36 into 10 to the power 4. And it is, you know, 1 by 10. So therefore the right option here is 1.1 Henry. Right option here is 1. Move on the next problem of this video session. In an electrical circuit, RLC and AC voltage source are connected in series. When L is removed from the circuit, the phase difference between the voltage and current in the circuit is pi by 3. When inductor removed, so circuit becomes capacitive circuit. That is tan phi is equal to, it is Xc capacitive reactance by ohmic resistance, and tan phi, it is pi by 3, that means root 3 equal to Xc by R. In this way you can say the capacitive reactance is equal to root 3 R. It is actually LCR circuit. The first information given here, if the inductor is removed, the circuit becomes capacitive, that is CR circuit, and the phase angle between current and voltage is equal to tan phi, it is pi by 3. So by simple calculation we can say X is equal to root 3 R. And when capacitor is removed, again the tan phi, the circuit becomes inductive, and tan pi by 3, it is XL by R, and XL becomes root 3 R. So interesting, when all the element all current element is present, nothing is removed, it is LCR. When all three these current element is present in the circuit, we can say here from this information we understood that Xc equal to XL. So the circuit is series resonant circuit. Series resonant circuits. You know, in series resonance circuit is equal to, in series resonance circuit, the capacitive reactance is equal to inductive reactance. Therefore, the power factor cos phi is the power factor. It is actually R by Z, and it is R, and the value of Z minimum, you know, it is actually R in series resonance circuit. So it is also R. So power factor is 1. So in series resonance circuit, you know, all time the power factor is 1. Right option here is 3. Next problem. The distance between an object and screen is 100 centimeter. This is object, and let us say one screen is placed at a distance. Screen is placed at a distance d. We can get the real image. In two either or positions, we can get the two real image on the screen in either or positions of the lens separated by 40 centimeter. And this is the displacement of lens. And the formula, simple formula, you have to use in the examination, in the particular type of competitive examination. Formula you have to use directly. Don't take the chance of deduction in the examination hall. You just use this formula. It is d square minus x square by 4d. And you know, 100 centimeter square, the positions apart is 40 centimeter square by 4 into 100. And we can say it is 140 into 60 by 400. And it is 21 centimeter focal length. Power, you know, it is 100 by plus F, 100 by 21. So the approximate power of this lens is 5D. Right option here is 2. Moving forward for the next problem. Electrical energy is transmitted over large distance at high alternating voltage. Which of the following statement is correct? For a given power level, there is a lower current. We know the power supplied for long distance. This is transformer. Power basically supplied at very high voltage and low current. So I is the transmission current. Transmission current is equal to P by V. So for particular amount of power is supplied from the long distance, if the voltage is high, normally it is supplied at very high voltage, so we can say the transmission line is very low, number one, and power loss for the transmission, it is equal to I square R, and R is the resistance of the transmission line. It is resistance for transmission wire. If I is very low current, we can say the power loss is also, it is very low. So this is why the particular amount of power is supplied very long distance, and it is at very high voltage. If the voltage is very high, then power is low, current is low, the transmission line is very low. If the transmission current is very low, we can say the power loss due to transmission is also very low. So for the given power level, there is a lower current. Lower current implies less power loss. 1, 2, both the option are right statement for this problem. It is the easy way to reduce the voltage at the receiving end using the step down transformer. Let us say the transmission current is I, and let us say normally it is supplied at very high voltage, 11,000 volt, and the output, it is 220 volt. So by using the step down transformer, we can easily, voltage can be transformed into our desired voltage, that is 220 volt. Let us say the domestic supply is 220 volts. So power supplied at very high voltage, but when we need a desired voltage of 220 volt for the domestic purpose, so we can, there is an use of transformer, step down transformer. So number 3 is also the right statement of this problem. So right option here, correct option here is 4. All these options given in this problem are correct option. Next problem of this session, in a 2-slit experiment with monochromatic light, fringes obtained placed at some distance from the slit. If the screen is moved, because of that we can get the change in fringe within 3 into 10 to the minus 5 meter. We know the fringe width for YDC experiment, lambda d by d, here d is the slit separation, we can get the change in fringe width due to the change in distance between slit and screen by d. In the problem, the change in fringe width given is 3 into 10 to the power minus 5 lambda, the change in the screen distance, into 5 into 10 to the power minus 2, and the slit separation given in this problem is 10 to the power minus 3 lambda. By calculation, simple calculation, it is 6,000 Armstrong. So correct option matches with 1. Let us see the next problem of this video session. In a diffraction pattern due to single slit with A, first minima is observed at an angle 30 degree. We know first primary minima sin theta equal to lambda by a. Therefore, lambda by a sin, it is given in the problem, is 30. In this way, lambda by a equal to half. The first secondary maxima is observed at an angle of, for first secondary maxima, sin theta equal to delta by a, and it is 2n plus 1 lambda by 2 is the path difference and slit width is the a. So putting for first secondary, we can get here 3 by 2 into a into lambda. You know, lambda by a here, it is 3 by 2 into half. So theta equal to, that is the diffraction angle for the first secondary maxima, theta equal to sine inverse 3 by 4. Correct option matches with 3. Let us see the next problem. In a single slit diffraction of light, wavelength is lambda is used and slit width is E. Simple question. We know central maxima with beta equal to twice lambda d by d. We know d is the slit separation and capital D is the distance between slit and screen. In the problem, 2 lambda screen distance given is B and the slit separation given in this problem is E. So very simple questions. The right option here is 2. And the next problem, a parallel beam of light of wavelength 4000 Armstrong gets diffracted by single slit width of 0.2 meter. First minima of diffraction, angular positions. First minima, we know sin theta, theta is the half angular width of the central maxima, that is the diffraction angle for first minima. It is actually lambda by a. Theta very small practically in reality. Since the slit width is very small, we can say that theta is very small. So the angular positions for the first minima, we can say lambda by a. Lambda given in this problem, 4000 into the power minus 10 and it is 0.2 into 10 to the power minus 3 and this is 2 into 10 to the power minus 3 rad. Correct option here is 1. Move on the next problem. Unpolarized light is incident on a plane glass's surface. What should be the angle of incidence so that the reflected and refracted rays are perpendicular to each other? We know from Brewster's law at a particular angle of incidence, reflected ray and refracted ray, the angle between reflected ray and refracted ray is 90. If it is angle of incidence, it is also the angle of reflection by the law of reflection. And angle of refraction, let us say it is R. So by simple geometry, IP plus R equal to 90 as per the Brewster's law. We know mu1, mu2, if we take mu1, mu2, so from Snell's law, we can say mu1 sine IP equal to mu2 sine R. It is the Snell's law, you know. So mu2 by mu1 equal to, it is sine IP by sine 90 minus IP, and it is sine IP by cos IP by cos IP tan IP equal to, we can write 1 mu 2, and it is actually given in the problem is mu. So IP, angle of incidence, it is tan inverse mu, and therefore tan inverse 1.5 for glass air combination. The value of tan inverse 1.5, it is the angle of polarizations, or it is the particular angle of incidence, so that the reflected ray gets totally polarized or completely polarized. Tan inverse 1.5, and this value, it is 57 degree. So for glass air combination, the angle of polarization is always 57 degree, and the right option here is 4. Next problem. In Young double slit experiment, a third slit is made in between the double slit. Then the fringes of unequal width are formed. It is not the right option here. The intensity of fringes totally disappeared. It is also not true. And only bright light is observed on the screen. It is also not true. So contrast of the unequal width are formed. Option 2 is the correct option. Next problem of this session. A thin mica sheet of thickness 1 into 10 to the minus 3 mm and refractive index mu 1.5 is introduced in the path of first wave. In the YDSC experiment, two slit is given and a screen is placed at a distance d. Screen distance is d. Slit separation, it is small d. Two wave meet at a point P on the screen, and because of the double slit experiment, we can get the fringes pattern on the screen, and a mica sheet, transparent mica sheet, if it is transparent mica sheet is placed at the upper beam of wave. Simple concept, you just keep in mind, any transparent sheet is placed in the upper beam of wave, the total fringes shift up, and if we place the transparent sheet at the lower beam of wave, the total fringes will shift down. So simple concept, when it is placed upper beam, fringes shift up, when it is placed in the lower beam, total fringes pattern shift down. Since it is the place in the path of first wave, it means that the transparent film is placed at the upper beam, so fringes pattern shift up. Immediately after this, applying this concept, we can cancel two answer here. The option 2 and option 4 are not correct, so 50-50 chances here, 1 and 3. And we know the shifting of fringes pattern is equal to, it is d by d mu minus 1 into t and beta lambda d by d. So just by comparing these two formula, del yn is equal to beta by lambda mu minus 1 into t. Beta, it is 1.5 minus 1 10 to the power 1 into 10 to the power minus 3 mm, and it is minus 6 meter, and lambda, it is 5000 10 to the power minus 10 meter, and by simple calculation it is beta 2 into 5 10 to the power minus 7, and it is 10 to the power minus 6. So finally it is 2 beta. So correct option of this problem is 2 fringes upward. Move on the next problem. When two coherent monochromatic beam of intensity I and 9I interference, the possible maximum and minimum intensity of the resulting beam are intensity maximum by intensity minimum. It is actually root I1 plus root I2 whole square by root I1 minus root I2 whole square root I1 by root I2 plus 1 whole square. It is also root I1 upon root I2 minus 1 whole square. Just by putting this 1 by 3 plus 1 whole square, it is 1 by 3 minus 1 whole square, 16 by 4. The ratio of the intensity maxima and intensity minima, it is 16 by 4, and the correct option here is maximum intensity is 16I and minimum intensity is I. So option 4 is the right option. Moving on the next questions of this video session. When light is refracted into the denser medium, if we take the two medium here, one medium is rarer and other medium, let us say, is denser medium. When light incident at an angle and it will refracted in the denser medium, refractive index of this medium is mu2 and this is mu1. Here mu2 greater than mu1. We know velocity of the light is v1 in the medium mu1 and the velocity of light is v2. Here we can say mu1 v1 is equal to mu2 v2 and it is all time it is constant. The product of absolute refractive index and velocity of light, it is all time constant. Actually this value of constant is 3 into 10 to the power minus 8. We can say it is C. You know, this is mu1 frequency lambda 1, mu2 frequency lambda 2 and mu1 lambda 1 equal to mu2 lambda 2. Frequency of light is the atomic property of matter, so frequency does not depend on the medium. Whatever may be the medium, frequency remain unchanged, but the wavelength, we can get the change in wavelength and henceforth the change in velocity of light. Its wavelength and frequency both increased. This is not the right option here. Its wavelength increases but the frequency remain constant. Since you know wavelength varies as 1 by mu, if the refractive index of the medium is increases, then the wavelength decreases. So therefore this is option 2 is not also the correct statement. Its wavelength decreases but frequency remains same. So 3 is the right option here. 3 is the right option here. Its wavelength and frequency both decreases. No question is asked the change in frequency. So correct option here is 3. Next problem. A parallel beam of light wavelength 500 nanometer on a narrow slit. In a narrow slit, a screen is placed at a distance d. Let us say the slit separation it is the positions of central maxima and we can get the minima on the both side of the central maxima. Minima of the central maxima. The distance of first minima from the central maxima is yn and the slit separation, we know this is linear slit separation is A, and the diffraction angle equal to theta, and from this formula yn by d is equal to sine theta. It is very instrumental formula. Delta by A. Delta is the path difference between the two interfering wave of the path difference between the wavelets originating through the edges of the slit. And for first minima, yn by d equal to, it is lambda by A first minima delta is equal to L lambda part difference, so therefore this is lambda. Slit width A is equal to B lambda by Yn. The value of D in this problem, is 1 meter. It is 1 meter, lambda given 500 nanometer, 10 to the power minus 9, and Yn given it is 2.5 into 10 to the power minus 3. And finally, be careful about the calculation. We can write it is equal to 5 by 2.5 into 10 to the power three plus 2, 5 plus 9 minus 9 minus 4, and it is 2 into 10 to the power minus 4 meter, and it is 2.2 into 10 to the power minus 3 meter, and finally the right option here is 2.2 mm. Be careful because one option is given here is 2 mm also. So the right option here is 3. Next problem. In a young double slit experiment, the source is white light. One of the hole is covered by the red filter, another by the blue filter. In the two slit, a white source is used in this experiment, but one is filtered by the red, another is filtered by the blue. So we can get only here, because of the filtration we get the red light, and from the other slit we get the blue light, and because of the interference of the two color, that is red and blue, due to the filtration in this case, so there is no fringes pattern will be formed on the screen. So here there shall be alternate patterns of red and blue. This is not the right option. One is incorrect. There shall be no interference pattern for the red distinct. That for blue it is also not the right option. There shall be no distinct interference fringes. So 3 is the right option. Next problem. Which of the following is the fundamental significance of Faraday's discovery? We know the Faraday's law induced EMF E equal to rate of change of flux, and it is ddt A B cos theta. We can write A cos theta ddt of B. So keeping the area of the coil A and cos theta is the projection to the magnetic field fixed, rate of change of magnetic field can produce the induced EMF. And induced EMF is the closed line integration over circuital electric field It is closed line integration over circular electric field is equal to, we can write A cos theta dB dt. It means that time varying magnetic field can time varying magnetic field produces induced EMF and hence electric field. And you know, electric field can exert the electrostatic force in an electrostatic force on a stationary charge. It is equal to Q into E. So a changing magnetic field can exert a force on the stationary charge. So this is actually, one is the correct option here. Let us analyze the other option given here. A changing magnetic field can exert a force on the neutral charge. No question is arise. On the neutral particle, electric field cannot exert a electrostatic force. So option 2 and option 4, that is both the neutral particle, the electric field cannot exert the force. So option 2 and option 4 are not the correct option here. And constant magnetic field cannot produce the induced EMF. So no. So option 3 is also not the correct option. Right option here, the time varying magnetic field, that is a changing magnetic field, can exert a force on the stationary charge. Let us move the next problem. A simple pendulum with bob of mass m and conducting wire of length L. It is conducting wire and the height of this, it is y, and this angle is given in the problem is theta. Length of the conducting wire given is L. So y is equal to, we can say, L minus L cos theta. So this is L1 minus cos theta and L into this is 2 sine square theta by 2. Velocity at this point, velocity at the lowest point of the oscillation V, we can write it is half mv square equal to mgy and v square equal to 2gl minus 2 sine square theta by 2. Finally, v equal to 2 root over gl, it is sine theta by 2. This is the maximum velocity of the conducting wire of the bob. The maximum potential difference induced across the pendulum. So induced EMF is equal to, we can write BLV, and this is B. The length of the conducting wire is given is L, and velocity it is 2 root over GL into sine theta by 2. So finally the answer equal to 2BL into root over GL sine theta by 2. V is the maximum velocity of the bob at the lowest point, and the induced EMF across the conducting wire is 2BL root over GL sine theta by 2. Correct option here is 1. Let us find the next problem. Eddy current are generated in insulator, conductor both 1 and 2 and neither 1 and not 2. We know eddy currents are the circular loop current within a conductor due to changing magnetic field applied on conductor according to Faraday's law. So eddy current are generated in conductor only. No question arise, it is in the insulator. Next problem, a square coil of side 25 cm having 1000 turns is rotated with uniform speed in a magnetic field about an axis perpendicular to the direction of the field. Okay, so induced EMF E equal to 200 sine 100 pi t, and it is E naught sine omega t. So therefore here the peak EMF is equal to A B omega into number of turns. This is the peak value of the induced EMF, and it is therefore we can say A B omega n equal to E naught. So magnetic field induction, it is E naught by A omega into n. Peak value in this problem, it is 200, and 25 into 25 10 to the power minus 4, omega equal to 100 pi, and number of turns is equal to 1000. And by simple calculation, you just pause this video and calculate this numericals, and this becomes 0.01 Tesla, there about 0.01 Tesla. So right option here is 4. Next problem, a horizontal straight wire 10 meter long extended from east to west is falling with speed 0.5 meter per second at right angle to the horizontal component of Earth magnetic field. So induced EMF E equal to it is B L V sine 90 and H E L V. Here HE is the horizontal component of geomagnetic field. And it is given in the problem 0.30 into 10 to the power minus 4 Weber per meter inverse 2. So induced EMF equal to, we can write 0.30 10 to the power minus 4 into length of the conductor is 10 meter and velocity is 5 meter per second. So finally it is answer is 2, 1.5 10 to the power minus 3 volt. So correct option here is 2. Let us see the next problem. The electron in hydrogen atom makes a transition from N1 to N1. Transition taken place from N1 to N2, N1 to N2, and time period T1, it is given 82. Time period of electron in the initial state is 8 times the time period that in the final state. And we know T proportional to N to the power Q by Z square. Here Z for the same atom, time period proportional to NQ. So therefore T1 is equal to, if it is given by the questions, it is T1 is equal to 82, and if we say it is N1Q and this become 8N2Q. So N1 is equal to 2N2. So quantum number of the initial state is 2 times the quantum number of the final state. So in this transition, if N1 is equal to 4, then N2 is equal to 2. So 1 is the right option here. Let us see the next problem. The ratio of speed of an electron in ground state of Bohr first orbit of the hydrogen atom to the velocity of light in air. We know mv square by r centripetal force provided by electrostatic force between nucleus and electron. So from this equation, orbital velocity square is equal to 1 by 4 pi epsilon 0 z square by m into r. And you know from the modern mechanics, angular momentum mvr is equal to nh by twice pi, and from this v equal to, we can say, nh by twice pi m into r. Okay, so comparing these two equations, it is the v square and it is v from the both postulates, we can say n square h square by 4 pi square m square r square is equal to 1 by 4 pi epsilon 0 z square by m into r. And from this equation, the orbital radius of the electron around the nucleus, we can say epsilon 0 h square by pi m square into z n square. Finally, the radius epsilon naught h square by pi m square n square by z. And you know, here z equal to 1 hydrogen atom and n is equal to 1. So the orbital radius of ground state electron epsilon naught h square by pi m square. Now the velocity of the electron of the first orbit, v equal to, we can say it is h by twice pi m r. R is the orbital radius, so pi m square by epsilon naught h square, and finally the velocity becomes m square by 2 epsilon naught into h. This is the orbital velocity of the electron in the first orbit. But the question is asked v by c. Therefore, cancel, already cancelled. So e square by 2 epsilon naught into h, we can write here e square by 2 epsilon naught h into c. So ratio of the electron v by c is equal to e square by 2 epsilon 0 hc, and the right option here is 4. Next problem. Two radioactive substance A and B have the decay constant 5 lambda and lambda respectively. At t equal to 0, they have the same number of nuclei. Let us say the A nuclei, it is n1 equal to n0 e to the power lambda 1 t, and for the B nucleus, number of active nuclei, initial new number of active nuclei, it is lambda 2 into t. As per the question, n1 by n2, it is given in the questions 1 by square and it is n e to the power minus lambda 1 t, and it is e to the power minus lambda 2 t. On simplification, we can write t into lambda 2 minus lambda 1. It is equal to e to the power minus 2. So t is equal to t into lambda 2 minus lambda 1. It is equal to minus 2. So t is equal to minus 2 lambda 2 minus lambda 1. And t, you know, minus 2, it is lambda minus 5 lambda. And finally, the answer becomes 1 by 2 lambda. So right option here, that after a time interval, the time is 1 by 2 lambda, and the right option here is 4. Move on the next problem of this video session. Select the correct statement. So we have to go through the all statement here. Beta radioactivity is the process in which electron is emitted from an unstable atom whose atomic number Z remain unchanged. You know, because of the emission of the beta particle, the atomic number of nucleus always changes by plus minus 1. So this is not the right option. Gamma radioactivity is the process in which the daughter nucleus has the atomic number 1 unit more than the parent. Gamma radiation is taken place after the emission of alpha and beta. So excited nucleus emits gamma radiation and attains the stable nucleus. So because of the gamma radiation, no change in the atomic number. So 2 is also not the right option here. Alpha radioactivity is the process in which unstable atom emits helium atom. So 3 is the correct statement of this problem. Need not to go. The alpha emission is the process in which heavy atom emits electromagnetic radiation of very high frequency. Alpha is a helium particle, so there is no question arise of the electromagnetic radiation. Gamma radiation is the electromagnetic radiations. Next problem 38. A ball of mass m strike the rigid wall with the speed at an angle 30 degree and get reflected with the same speed. We know it is the residual. A ball collides with the residual at an angle 30 degree and it is reflected with the same speed. If the speed of this is, let us say it is u, and thus with the same speed the particle reflected at an angle 30 degree. So the velocity component or the component of momentum, it is actually mu cos theta, and the component normal to the wall, it is also mu cos theta after reflection. So change in momentum we can say del P equal to, this is plus mu cos theta minus mu cos theta. So total change in momentum is equal to 2 mu cos theta. when ball just collides with the wall, there is an action reaction, and reaction always acts normal. Reaction always acts normal. Reaction always acts normal to the wall. So we can say reaction is equal to action. It is rate of change of momentum. Change in momentum is equal to 2mu cos 30 degree by time of impact is t. So right option here is 4. Next problem of this session. A boy prevents fall of the book on the ground by pressing it against a vertical wall. It is actually vertical wall. A book is pressed by an force F. So the normal reaction by the wall to the book is N, and the weight of the book acts downward, and friction prevents the book from the falling down. We can say F equal to mg, and friction is equal to mu n equal to mg. You know, according to Newton's third law, normal reaction is equal to the action given by the boy on the book. So this is action reaction. We can write mu F is equal to mg, and the minimum force needed by him in his attempt. So the minimum force required to keep this book to prevent this book from falling down, it is mg by mu, and here m equal to 10 kg, and the value of 10, it is 10, and the value of mu, it is 0.2. So the right option here is 500 Newton. This is the minimum force needed by him in his attempt. So right option here is 3. Let us move the next questions of this session. A meter scale is moving with uniform velocity. This implies the force acting on the scale is 0. But the talk about the center of mass can act on the scale. Since there is no the force acting on the scale is 0, talk about the center of mass can act on the scale moving with uniform velocity. Since the scale moving with uniform velocity, we can say the external force as per the Newton first law. If there is no external forces applied on any system or on the system of particles, the system remains at rest or continues uniform velocity. The force acting on the scale is 0, and the torque acting about the center of mass of the scale is also 0. There is no question arise, when any body is moving with uniform velocity. So here we can say the F external force is 0, and the torque applied is also 0. Since in the given questions, scale meter is moving with uniform velocity, so right option here, the force acting on the scale is 0, and the torque acting about the center of mass of the scale is also 0. So option 2 is the right option here. V, P and E denote velocity, linear momentum, kinetic energy of the particle respectively. We know kinetic energy equal to half m v square, differentiating both sides, differentiating both sides with respect to velocity, we can write this is dE dV and it is half m ddv of v square, and it is dE by dV half m and 2v. This becomes m into v. So the momentum equal to, we can write ddv of kinetic energy. Option 1 is here. Directly 1 is the correct option here. Next problem. A book of mass 10 kg moving x direction with constant speed of 10 meter per second is subject to retarding force 0.1 xj joule per meter during traveling from 20 meter to 30 meter. Final kinetic energy. So first of all, we have to find out the initial kinetic energy. Initial kinetic energy E1 is equal to half m u square, and this is half mass of the body, it is 10 kg, and the velocity is 10 square, so 500 joule is the initial kinetic energy of the particle. So one particle is moving with initial kinetic energy 500 joule, but a retarding force is given. Because of the retarding force, the velocity of the body goes on decreasing and retardation produce. So work done, let us say it is moved from this point to one point to another point by the displacement is x. So work done by the retarding force is equal to f dx. Not necessary to use your cos 180, that is minus sign. Here is a retarding force because of the, just we have to find out the magnitude of the work done by the retarding force. And retarding force given in the problem is 0.1 x into dx. So we can write here 0.1 integration x dx, and initially 20 meter to 30 meters. It is 20 and this is 30. And 1 by 10 for the simplification, it is x square by 2. This is 20 to 30. So 1 by 20, 30 square minus 20 square. We can do this job. 1 by 20, it is 50 into 10 and 25 joule. So work done by the retarding force on the particle is 25 joule, and this amount of energy will be decreased from the initial kinetic energy. So final kinetic energy equal to initial kinetic energy minus work done. This is 500 already been calculated, and kinetic energy work done 25 joule, and finally the answer, and the final kinetic energy is equal to 475 joule. Correct option here matches with 1. Let us move the next problem of when transformation Z 90 and at mass number is 228 and transformation taken place, the new atomic number 83 and the mass number is 212. Here we have to find out the number of alpha particle emission n alpha equal to atomic mass number previous and new mass number A prime by 4, and it is 228 minus 212 by 4, and number of alpha particle emission is 4. Option 1 is not correct here. Let us check the number of beta particle emission n beta is equal to 2n alpha minus z plus z prime. You know, mass number is decreased by beta particle emission is 2, by alpha particle emission is 2, and number of alpha particle emission here is 4. We can write this is 2 into 4 minus 90 plus 83, and it is 91 minus 90, so number of beta particle emission here is 1. So correct option matches with 4. Let us move the next question of this session, that is 44. A body is moving unidirectionally under the influence of source of constant power. You know, power is constant. The power delivered by the engine of the car, or that is power delivered on the body, P is equal to constant. We know the dimension of power is equal to ml square t to the power minus 3 equal to constant. This power is constant. Capital L, dimensionally it corresponds to displacement, and time corresponds to capital T corresponds to time. So from the dimensional analysis we can write x square proportional to t to the power q, since the power is constant. So displacement of the car x varies as t to the power 3 half, and the power is greater than 1. So this equation can corresponds to the parabolic equation. So with the rise of time, the displacement is increasing. Here, so option 1, it is straight line, so no question arise. And option 1 and option 3 are not the correct option here. Here the displacement d and time is given. It is parabolic in nature, and it is also the parabolic in nature. But here with the increase of time, the displacement is increasing, but in the decreasing order. So option 4 is not the right option. With increase of time, the displacement of the particle increasing, the displacement of the particle goes on increasing. So option 2 is the right option here. I think you are understanding all the method of the solution, which already I have discussed. Next problem, question number 45, that is the last questions of this video session. A bolt of mass 0.3 kg falls from the ceiling of an elevator moving down with uniform speed. It is very important information, uniform speed. Since the elevator moving down with uniform speed, that is acceleration equal to 0, we can say this frame is inertial frame. So in any inertial frame, the all Newton's laws of motion are hold good. So any bolt that is falling down, the elevator length is 3 meter. Since this frame is moving with uniform velocity, so moving down with uniform velocity, so this frame is the inertial frame. So we can directly use any formula, or particularly the Newton's laws of motion here, and it will relatively strike the ground with the velocity, it is root over 2gh, and the kinetic energy, that is kinetic energy, that will come from the potential energy, and this kinetic energy, if it is completely, it hits the floor, the elevator, and does not rebound, what is the heat produced by the impact? If we think the total kinetic energy is converts into the heat, then the heat energy produced in this case is equal to mgh, and the mass of the body, it is 0.3, and value of g, it is 10, and the height of this is 3. It is actually 9 joule. I have taken here the value of g is 10 meter per second square, and the answer is 9 joule, but no such answer is given here. So I think in this case, if we take the value of m, it is equal to mass of the body is 0.3, and the value of g is taken, it is 9.8 into 3. So I think the answer will be the 8.82 joule. By default, I have taken here 10 meter per second, that is the maximum value of g. But actually, in this problem, if we take the value of g is 9.8, so the right option here is 2. So in this way, we have discussed 1 to 45 questions and their method of solution.